Assalamualaikum and welcome to everyone. My name is Muhammad Khairul Ridhzwan bin Roslan, Mechanical Engineering Semester 7. This semester, I will present my final year project for my FYP1. My final year project topic is Design and Simulation of Assembly Line using Blending Software. And I are Dr. Noor Azlina Salleh as my supervisor for my FYP1. Now, I will continue the presentation. Okay, continue. Project summary. This project is a study Karakuri assembly line design. The Karakuri system is a mechanical device that improve work in general. The device use only mechanical gadgets and provide hydraulics, pneumatics or electrical power. An assembly line is a production process that divide up the level process. It divide the process of making a product into phase that must be done in a specific order. The assembly lines play an essential role in storing and providing the memory stationary holder, which must be assembled during operation. This project aims to design by using KTB5 software and make the simulation of the assembly line by using Blender software. The primary goal of this final year project is to ensure the Karakuri assembly line system can be successfully simulated on the schedule. Aside from that, the project kills goals are to determine whether Karakuri system can effectively reduce the dependency on the electric conveyor assembly line. Introduction and background for the Karakuri system. It was invented in Japan in 70 to 19th century and is original with the mechanical dolls in Japan called Karakuri Ningyo. Its memory relies on the simple workforce, weak and gravitational pull to control the manipulate the system movement. The Karakuri system is used in the most production line to transport goods from one workstation to another work without requiring any power. Besides, Karakuri is well known as a mechanical device using natural physical phenomena such as gravity force and electromagnetism and elemental mechanism such as spring, lever, rollers and its production. The Karakuri also is the mechanism activated through the springs, gear and other analog system. It uses the law of gravity, the principle of the lever, the spring, the cam, the pottery and so on ingeniously. Karakuri technology is a unique system developed in Japan that's intended to use natural physical phenomena such as gravity, wind and electromagnetic power and elemental mechanism such as levers, links, force transmission and pulley mechanism. For the literature review, I used to search that related with the Karakuri system, which is consists of basic Karakuri mechanism, Karakuri Kaizen, lean manufacturing, material handling and ergonomic. This keyword search will help to design 3D concept for my assembly line that implement Karakuri system. For my literature review, I have found many 3D design concepts which consider assembly line that using Karakuri systems, such as the figure 1, that showing concept of vertical forms that influenced by Japanese lean manufacturing principle Karakuri Kaizen. On the article that conducted that by Targehan Alan bin Muhammad, that which is implementation of lean manufacturing principle in a vertical farming system to reduce dependency on human labor, shows 90% of 36 seedling of cabbage have grown successfully within 6 weeks with implementation lean manufacturing. In this journal shows that the prototype adopts Karakuri Kaizen lean management principle to allow the mechanical movement of growing trees which reduce vertical and horizontal movement that necessary suggestion robot and maximize space for any typical factory layout in cultivation area. Then, in figure 3, the simple Karakuri structure for handling operation using gravity. That desire to increase productivity can be effectively achieved by their characteristic small, medium-sized company adopting low-cost automation. Okay, now go to the problem statement. The production rates refer to the run number of the products that can be produced daily in terms of manufacturing. As a result, product quality must be considered to ensure that the country has high production rate. This issue here is that if the product have too many flaws, the production rate will suffer. Many defects may occur because of workers who lack the focus. The operator who work on the production line may become tired or bored because they must perform the same task every day. As a result, they are unable to concentrate on the task at hand. Furthermore, the common problem in manufacturing is ergonomic condition of the operator. This means that operators sometimes must bend their bodies to take poly boxes or boxes from the floor. If the operators bend their bodies each day, they may have back pain and feel tired. In addition to bending their body, the operators will also get tiredness and pain in the legs if they stand about 8-hour days to do their work. If they feel tired and uncomfortable, there will surely a human mistake and defect in the products. Inefficient and inefficient working methods will therefore contribute to low productivity and employability. Therefore, the employer and management of company must find out something so that ergonomics problems such as the use of Karakuri Kaizen are reduced and perhaps eliminated. Next, for my final year project objective is to study the type of Karakuri assembly lines with its mechanism. Second is to design Karakuri assembly line, which means to design assembly lines must based from the Karakuri system such as Kaizen or lean manufacturing and so on. And last, to analyze and simulate the Karakuri assembly line. After base sketching and design 3D in CATIA V5, trying to simulate the design on blending software. Scope and limitation. This study will focus on designing Karakuri assembly line with the specific product multi-purpose holder. A flexible and adjustable assembly line is targeted to be designed in order to allow better possibility for different type of assembly line layout and type of products. As known, uh, the limitation for this project is the design cannot be fabricated because due to the pandemic COVID-19, the design only can approach on the simulate blending software. For the methodology, I use PDCA methods, which is a good method for process and product control and continuous improvement. First, for the plan phase, the planning phase is the most important phase because it will affect the final products. The first step is to identify problems that affect efficiency of the process. Literature review from various sources will be helpful in obtaining design ideas as well to improve knowledge about Karakuri system that involve Karakuri Kaizen, lean manufacturing, material handling, and ergonomy. Next, the do phase. There are three conceptual designs that have been generated. PAC method is the use to determine best design. The product is designed by using CAD software and simulated by using Blender software. For the check phase, then review the design assembly lines with the team, industry expert, and supervisor. The design will be re-evaluated to improve the functionality and stability. And last, for the act phase, this phase is further adjustment and tuning will be carried out by the defect identified and feedback obtained during the checking phase. That the final report submission, all information and documentation on the inventory management system will be compiled and be reported. Now, we go to the expected result. The figure in slide show the design concept that has been generated in CATIA V5, which is the design concept 1, design concept 2, and design concept 3. To make right decision for choosing the design concept, I use pie charts to find which better for the design concept. Uh, that pie chart is the selection criteria is functionality, ease to maintenance, ergonomic, durability, and easy to use. Can assemble product also easy to assemble and disassemble. As can see, the design concept 3 is the fulfill the requirement of the selection criteria as the third conceptual design from the pie chart above that the best among other designs and the highest score is 5. This design is good for ergonomic lasting complete product assembly, comparing to the other two, 1 and 2 design concept, which is cannot assemble the whole product. After making the decision from the part chart, also discussion with the supervisor, they decide to choose design concept 3 as the final design concept. Then supervisor agree to continue with design concept 3. Then I start to make the simulation using blending software to to present how the product works on the karakuri assembly line. For the Gantt chart, this is my project planning, which is a consist semester 7 and also semester 8. In semester 7, I do more literature review and identify the research and problem to make sure on semester 8 really easy to continue the final year projects. After successful simulation is demonstrated for the design concept 3 movement using Blender, then the further improvement in terms of the design and simulation will be contributed on the next research stage. For the conclusions, the assembly line, what's make assembly line using Karakuri system is good. Many study that I found by implementing Karakuri system, it can optimize process, relieve strain, improve efficiency, fast, save on space, simplify work, and to ensure flexibility and compatibility. Furthermore, sometimes implement Karakuri system not only can uh, can only use gravity force, not using other resource like electrical or hydraulic. That's all. Thank you.